It's a mandatory proof, okay, proof of the Moivre theorem by induction, okay. Why am I doing this now? Because you do it by induction, and there's also a lot of trig in it. So induction is fresh in our brain, trig is fresh in our brain, so that's why I'm doing it now. And don't worry about what you have to prove and what you've not. I have a list of everything inside the school, I'll give you that, okay. Right, so remember the Moivre theorem was, if I wanted cos theta plus I sine theta to the power of n, it's cos of n theta plus I sine n theta, okay. So that's what I'm trying to prove, right? Okay, so for my induction, you prove it's true for n equals 1. So prove true for n equals 1. So that means cos of theta plus I sine theta all to the power of 1. Does that equal to cos of 1 theta plus I sine 1 theta, and yes, that is true. So that means cos of theta plus I sine theta on this side equals cos of theta plus I sine theta, and that is a true statement, so that's step 1 done. Okay, next one is we're going to assume it's true for n equals k. Okay, so everywhere I see an n, I'm going to put in a k. So cos of theta plus I sine theta all to the power of k is equal to cos of k theta plus I sine k theta. So this is a fact, right? Okay, and then the next thing is I want to prove it's true for n equals k plus 1. So this is my to prove line is next. Okay, so I want to prove that cos theta plus I sine theta all to the power of k plus 1 equals cos of k plus 1 theta plus I sine k plus 1 theta. Okay, so that's what I'm trying to prove, right? So I'm going to start off my proof now. So you all start your proof with the fact. So this is the only fact I know. So cos of theta plus I sine theta all to the power of k equals cos of k theta plus I sine k theta. Okay, so I want to turn this line into this line. Okay, I'm moving it up a small bit now. Okay, so I want to turn this line into this line. Okay, so if I multiply each side, multiply side by cos theta plus I sine theta. Okay, so if I multiply cos theta plus I sine theta to the power of k, that's the left side, and I'm going to multiply that by cos of theta plus I sine theta. Okay, and over the other side I have cos of k theta plus I sine k theta, and I want to multiply that by cos theta plus I sine theta. Sorry, small and squash, but it's there. Okay, right, at this side I end up with cos theta plus I sine theta to the power of k, and this is that to the power of 1, so that means that's cos theta plus I sine theta all to the power of k plus 1. So now the left side looks like what it should look like. Now the right side, so I have to go from this up to this. Okay, so to turn this side into this. So obviously the first thing you do is multiply out. So I have cos k theta plus, sorry, cos k theta by cos theta. Then I'll go cos k theta by I sine theta. Then I have plus I sine k theta by cos theta, and then when I multiply this by this, I'll get I squared sine k theta plus, or sorry, I squared by sine theta. Okay? So my left side is the way I want it to be. I need to work on this to turn it into this. Okay? So what I'm going to do is I'm going to put the minute you see I squared, change it to -1. So I'm going to make this cos k theta, cos theta. Now, I'm going to change that I squared there to a -1, and I'm going to write that one term next, minus sine k theta, sine theta, and then I see the way there's an I common to both of these, so I'm going to take the I outside the bracket, plus I times cos of k theta sine theta, cos k theta plus sine k theta cos of theta. Okay, so what this is this broken up. This is actually cos of A plus B broken up. So cos of A plus B is cos A cos B minus sine A sine B. Okay, right, so the first one is cos of A plus B broken up, so that's cos of A is k theta and B is theta. And the second bit, girls, is cos sine plus sine cos, that's sine of A plus B broken up. Okay, so that would be sine of A is k theta and B is theta. Okay, so that would be, right, that's equal to cos of k plus 1 theta, just taking the theta outside the bracket, okay, plus I sine, take the theta outside the bracket, and you have k plus 1 theta. So you've just proved what you wanted to prove. So the left hand side is the same as the left hand side, the right hand side is now the same as the right hand side. So you have just proved what you want to prove. So then you say it's true for n equals 1, it's true for n equals k, it's true for n equals k plus 1, therefore it's true for all n element of n. Okay, that's the Moivre's theorem.